Welcome to Van-Gelder Tutoring and welcome to part 1 of the atom. This video will cover the first part of everything you need to know about atoms for the first year of your chemistry A-level. To start with, this is a diagram of an atom. All matter is made up of atoms which contain protons, neutrons and electrons. The protons and neutrons are found in the center of the atom, which is known as the nucleus, while the electrons are found in orbitals surrounding the nucleus. They're called orbitals because the electrons circle the nucleus in a similar way to how the Earth orbits the Sun. You also need to know some additional detail about these subatomic particles, though you will probably have covered this at GCSE. Protons have a relative mass of 1, as do neutrons, while electrons have a mass of 1 over 2000. At GCSE you may have been taught that electrons have a mass of 0, as some specifications do use 0 instead. And while their mass is much lower than the mass of protons or neutrons, it's important you know that the mass is in fact 1 over 2000 rather than 0. Protons and neutrons are found in the nucleus of an atom, which means that the mass of an atom is concentrated in the nucleus. They often like to bring this up in exams and ask where the mass of an atom is concentrated. The answer is, of course, the nucleus. Protons have a charge of +1, while electrons have a charge of -1. When writing the charge, ensure to always put the positive or negative symbol. Students who lose marks on questions related to the atom usually lose them because they write the correct number, but then also forget to write whether it's positive or negative. Neutrons, however, have no charge, which you denote as 0. Again, another way in which students slip up here is by writing no charge rather than the number 0. Unfortunately, the specifications are very specific about how you answer these questions, so I suggest maybe memorizing the table that's currently on screen. Nuclear symbols come from the periodic table. You should have been provided with a periodic table that is specific to your specification, but please be warned, if you do use one online, you will most likely find that the numbers shown on that periodic table are different to the ones on your specification. As I'm sure you've realised throughout studying science, that what's taught at GCSE and A-level is simplified a little bit, because trying to teach the full concept to get you to fully understand it would just take too long. The same is also true with the periodic table. Almost every element has a mass that includes a decimal, and for the purpose of A-level study, that simply isn't included. So please stick to the periodic table that is provided to you specifically for your specification. Now, in terms of nuclear symbols, this is a nuclear symbol taken from a periodic table, and there are 3 bits of information that are displayed here. The first is the mass number. Now, the mass number is always the highest number shown. Sometimes the 2 numbers are swapped round so that the highest number is at the bottom, and sometimes it's at the top. Generally speaking, for the A-level specifications, it will be shown at the top. The mass number tells you how many protons and neutrons there are inside an atom. So if you add the number of protons to the number of neutrons, it will give you the mass number. Next, we have the atomic number. The atomic number is sometimes referred to as the proton number. It tells you how many protons are found inside the nucleus of an atom. And of course, lastly, we have the actual element symbol itself, in this case He, which corresponds to helium, and you can of course check these on a periodic table. Now, some important information to note from this. The number of neutrons isn't displayed on a nuclear symbol. The way you calculate the number of neutrons is you take the mass number and you minus the atomic number, as of course if the mass number is the number of protons and neutrons, and the atomic number is just the number of protons, the difference between the two must be being made up by neutrons. Another important thing to note is that the number of protons in an atom is always equal to the number of electrons. This is only true for atoms. It does not work for ions, as you'll see shortly. One of the most common questions you're going to be asked in your A-level is to fill out a table that looks exactly like this. Only the nuclear symbols will often be given to you. You will be expected to work out the atomic number, mass number, number of protons, electrons, and neutrons. So let's have a quick go at this. We're going to start off with helium because it's the one we've just looked at. So there's our nuclear symbol. Let's see what information we can get. The first thing it wants to know is the atomic number. Well, we already know that the atomic number is shown. It's 2. Mass number, again, is also shown in the nuclear symbol, so we can immediately say that that's going to be 4. Protons, well, remember from the previous slide, the number of protons is always equal to the atomic number, therefore we can also put 2 for that. And again, from the previous slide, the number of electrons in an atom is always equal to the number of protons, therefore there's also going to be 2 electrons. And in terms of neutrons, to calculate the neutrons, it's the difference between the atomic number and the mass number. With an atomic number of 2 and a mass number of 4, we also know there's going to be 2 neutrons. Helium is a nice one. They're very unlikely to give you that in an exam, however. Next up, we've got lithium. The atomic number for lithium, again, we can see it straight away, is going to be 3. The mass number, again, shown straight away, 7. Now for the number of protons. Well, protons is always equal to atomic number, so again, 3. And the number of electrons is always equal to the number of protons, so 3. Whereas this time, neutrons, it's the difference between the mass and the atomic number. Our atomic number is 3, our mass number is 7, so of course our answer is 4. And lastly, magnesium, slightly bigger numbers this time. We can zoom through the atomic numbers and mass numbers quite quickly, as we can quite clearly see them. We have to remember that the number of protons is equal to the atomic number, therefore 12. The number of electrons is always going to be equal to the number of protons in an atom, and the number of neutrons is the difference. The difference between 12 and 24 is, of course, 12. Now, you may look at this and notice that the number of protons, neutrons, and electrons in most cases is more or less even. This is a common thing with atoms. They do tend to have fairly similar numbers of protons, neutrons, and electrons, but it is not always the case, as you can see with lithium. Do make sure you double check them. These are one of the most common areas that people make errors with in their exam. In first year, this is one of the most common exam questions, and the most important thing to remember is mass number minus proton number is how you calculate the number of neutrons, and always double check your math. Type it into your calculator fast. The number of students that lose marks on these questions is truly astounding. Ions are a little bit different. Ions have different numbers of protons and electrons, unlike atoms, which always have the same number of protons and electrons. Because of that, the charge becomes unbalanced, and overall, the atom itself then has a charge. When an atom has a charge, it's no longer referred to as an atom, but instead is described as an ion. One of the most common ways people lose marks on exams is by saying atom instead of ion. Let's look at some examples. To start off with Cl-. Now, Cl- is a negative ion with a charge of -1. What that means is that there is one more electron than there are protons. Chlorine has 17 protons, which you can check by looking at the periodic table. Therefore, Cl- must have 18 electrons. We can see this in the diagram here that chlorine has gained 1 electron, and it's shown in red, while the electrons it has natively are shown in blue. Beryllium is an example of a positive ion, which is Be2+. What this means is that there are 2 more protons than electrons. Beryllium has 4 protons, therefore Be2+ must have lost 2 electrons. Again, we can see this in a diagram. Beryllium has lost 2 electrons, and its remaining electrons are shown in red. Something that's important to remember is that the number of protons an atom has cannot change. If the number of protons changes, it becomes something else, and we get into nuclear physics. In chemistry, we only look at the electrons changing. So if you ever see an atom with a charge, we refer to it as an ion, and we remember that the number of electrons has changed. That concludes part 1. Click on the link to head straight over to part 2. Thanks for watching.